Mr. Morgan into you financial advisor, it's afternoon. Oh, what you doing? I'm calculating the area under this curve. It's a cosine curve, so I'm using the integral of the function. It looks like a mustache. Well, I've got the function here, and it goes from here to here, so I integrate it like this. And then I use the fundamental theorem of calculus to subtract f at b minus f at a, and I get the area. You could use it for mustaches, but I don't know why you would do that. And you could use it with a cotangent curve. Cotangent? Speaking of coats, would you like to buy a tie? How did you get coat out of cotangent? More importantly, how did you get tie out of coat? You know, coat, tangent, coat. Never mind. How did you get to the subject of ties? What's the matter with you? Don't you remember? I run a tie business. Ties and mustaches. And I need help with getting more profits and stuff. So you want to optimize your profits? No, I mean yes. Well, first to optimize, you want to take y and y prime. So you're finding Optimus Prime, the Transformer? Well, you can transform if you want to find y prime, and you have like a baby function inside a mommy function, and you transform the baby into AU. Then you use the chain rule. Isn't that like abuse, using chains on babies? So anywho, first what you to do is decide what your variables are and how they are related. Well, I guess mustache and tie sales would be varying, and I get the bow ties from my dad's side. The mustaches I get from my mom, so they're related by marriage. So, well, you're gonna have to know how to derive the function so that you can find the maximum point of money and profits and salary and whatever else you make. Why would you need celery? Celery is gross. Salary, make salary. I don't make celery. I make ties. Well, do you know? Well, okay. Let's pretend that this is your function. 3x squared minus 5. Y equals that. But that's not y, that's 3x squared, and that's not even a function. That's my pet. No, this is a function because if you graph it, it passes the vertical line test. I don't like tests. Well, too bad, because there's a lot of tests in calculus. There's a second derivative test, but I'm not strong enough to take tests. Well, I am. Thanks, P90X. P90X, is that a function too? What? We were talking about deriving under the influence or something. Or you are differentiating under the influence of the rules and properties of differentiating. What? Well, there's the power rule, the constant multiple rule. There's rules for trig functions, and you just have to memorize those. Then there's the quotient rule, and you have a little round to remember it. How does it go? Low D high minus high D low, square the bottom, and away we go. Ooh, let me try. When you differentiate, you have to know the rules. There were a bunch of them. The end. No would have to rhyme, like pause. I know. For the power rule, it could be bring the power down to the floor, then kick one power out the door, like that. Now you try that rule. Come up here and write it out. Write a function first. Okay, what function? Do x to 1/2 power minus. Wait, what's that? That's a ninja. No, you won't be needing that. You should kick the power out the door. Ninjas kick stuff like bricks and boards and trees. Speaking of trees, we need to talk about logs. Logs, natural logs, you write them like this. To derive the natural log of x is 1/x, and what are you doing? I'm drawing my log. Well, you can't derive a picture. I gotta go, 'cause I can't be talking to you all day. I've got time limits. Wait, we forgot to talk about time limits. About limits. You can't use the limiting process to derive and integrate. Come back.
Screen test for Murray Moore. So Murray, what do you know about calculus?
All I know is, well, these magics stick together, but that's not having to do with calculus. All I know about calculus is 3x squared equals y, just from the script.
Is that all?